Hello student, this is Ravindra Khandelwal before you with a new exercise 1.3 of same chapter number system from your NCERT 9th class maths book. I am going to start this exercise today and definitely will cover it completely. The first sum of the exercise already has been written on this whiteboard. The sum is saying write following decimal and say what kind of the expansion each has. Sum is saying कि आपको डेसिमल्स लिखे हुए हैं और उनका क्या एक्सपेंशन है आपको बताना है. Now the first decimal number is there 0.36. What is mean by 0.36? I want to tell you, you have already been taught by me what kind of the decimal expansion a number can have. Now you have to identify, because after 6 there are no any digit, so it stop here. It means 0.36 stop here. The number whose decimal has been stopped, that is known as the terminating. So its decimal expansion is terminating decimal expansion. Now we will go for the next. Now what is this? This number is 0.09 and there is a bar above the 9. The mean of the bar is that it is like that 0.0999 so on. So if the number is like that 0.099999 so on up to infinity, it means it is not stopping itself. It is not stopping, so we can't say it is a terminating. If we can't say it is a terminating, definitely it is non-terminating. So first of all, we will write non-terminating. Now one thing we have to observe, but the 9, there is a repetition of the 9 again and again. That's why this number is non-terminating but repeating. You can also write the word recurring instead of repeating, but I am writing here repeating. Now we are again going for the third part. That number is 4.125. You already know this number, decimal expansion of this number also stop after 5. So this is also terminating. Now we are going for fourth one. Now you are observing here the number is like that 0.230769 and bar above that block. It means the number is like this 230769, 230769, 230769 and so that. Now if the number is like that, it is same non-terminating, because it is not stopping itself. But there is also a repetition of this block. There is a repetition of this block. So it is also non-terminating but repeating. Now we are going ahead and I am going to start the second sum. The next sum, the sum 2, number 2 is saying, you know that 1 upon 7 is equal to 0.142857 and there is a bar on this block. Okay, can you predict what that decimal expansion of 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7 and 6 upon 7 are without actually doing long division? It means you have need not to do the division, but you have to tell, you have to predict what the decimal expansion of this number will be. So I am going to tell you how you will find out, how you will get it. One thing I want to tell you guys, 2 upon 7, or we have to find out the value of the 2 upon 7. You know very well 2 upon 7 can be written as 2 into 1 upon 7. It means 2 into 1 upon 7 again can be written as 2 into, you having the value of 1 upon 7, put here the value of 1 upon 7, that is, and just going, you have to multiply it by 2. 2 sevens are 14, 1 carry, 2 fives are 10, 11, 1, 2 8s is 16, plus 1 17, again 1, 2 2s are 4 plus 5, and 2 4s are 8, 2 1s are 2, and after that point 0, and there is a bar and you put a bar there also. Similarly, I have done of 3 upon 7 and 4 upon 7. You again you can write 3 upon 7 as 3 into 1 upon 7 and 4 upon 7 as 4 into 1 upon 7, and again you have to multiply like that, and similarly you can find out the 5 upon 7 and 6 upon 7. This is your homework. You have to do yourself. Now I am going for next sum number 3. I am here with a new sum 3. Express the following in the P by Q form, where P and Q are integer and Q not is equal to 0. You have given in these parts the decimal expansion of the rational number. So you have to write the rational numbers decimal expansion in the P by Q form. Now I am going to teach you how can you write this, okay, in the P by Q form. First of all, the number has been given you the 0.6 and there is a bar above the 6. So you can write a let x is equal to 0.6 bar. But you know already, my dear student, 0.6 bar can also be written as 0.66666 and up to infinity, so on. So I am repeating here, I am putting here 3 dots. Now you can give it equation 1, okay. So after that, what we will do, we will multiply it by 10, because I want to tell you what. So I will write here multiply equation 1 by 10. If I am going to multiply equation 1 by 10, then I will get here 10x is equal to 6.666666 and so on. This is equation 2. You already know how to multiply. If you are multiplying it by 10, the one digit will come there. So 6 already has come here at the place of the 0. Okay, 6 has come. Now this 6 is here. Now this 6 is here. This 6 is here. This 6 is here, and so on. Okay. Now what to do next? Subtracting equation 1 from equation 2. Now I am going to subtract equation 1 from equation 2. This is equation 2, this is equation 1. So I am going to subtract equation 1 from 2. It means 10x minus x. I have to write here 10x minus x. So simply you can write here 9x is equal to. Now you have to subtract this part also, right hand side, 6 minus 0. So this is 6. After point there will be 6 minus 6, 0, 0, 0, 0. Everything is 0 after the decimal. There is no value of that 0. So we will not mention it. So 9x is equal to 6. So x is equal to 6 upon 9. So x is equal to 2 upon 3. Answer. I think you got it. 2 3 ja. Sorry, I am sorry. 3 2 ja, 3 3 ja. Now I am going for next part. Similarly, I will do it. Solution second. Let x is equal to 0.47777. So there is a repetition of the 7. Now I am again multiplying it by 10. So 10x will be 4.77777. Now this is equation second. Now if we subtract here 10x minus x, 9x, it is okay. But what will be here? 4 minus 0, okay, it will be 4 point. But when you are going to subtract 4 out of 7, so this will be 3, so result will be 4 upon 3, okay. But we need not to find out the result in the form of the decimal, okay. But if you will directly subtract here, the result will be 9x is equal to 4.3. Again you have to remove the decimal. So what we will do now, I am again multiply it by the 10. So this one becomes the 100x is equal to 47.7777 and equation 3. Now what you see here, you can subtract equation 2 from equation 3. So writing here, subtracting equation 2 from equation 3. So you will get here 100x minus 10x. This is 90x is equal to 47 minus 4. This is 43, and here it will also be the 0, and there is no value. There is no need to write the 0 after the decimal. We will simply neglect it. Okay. So x is equal to 43 upon 90. This is the P by Q form of this decimal expansion. Now student, this sum you have to do yourself. You have to try. And if you are having any doubt, ask me in the comment box. Again I am with the new question, the new sum, 4 sum. The sum is saying express 0.99999 in P by Q form. Are you surprised by your answer? The sum is saying if you get your result in the P by Q form, will you surprise with it? We see why we have a surprise. Okay. So let, again I am solving, let x is equal to 0.99999 and I am going to give the name equation 1. Now again you have to multiply it by 10. Again I am going to multiply equation 1 by 10. So you will get here 10x is equal to 9.999 and so on. Okay, there is no termination. So after that we are going to subtract. So I am writing here subtracting equation 1 from equation 2. So what I am writing here, I am subtracting equation 1 from equation 2. So the result is 9x is equal to 9. So because 9 minus 0, 9, and this will becomes a 0. So x is equal to 9 upon 9. So x is equal to 1. So this is surprising me, definitely, because the number is 0.9999. It means it is less than 1. But result in the P by Q form is 1. Because it is, why it is happening like that? Because the gap between the 0.9999 and the 1 is so less, which is negligible. Okay, so they are very close to each other. So we can consider 0.99999 as a 1. That is the point here. Okay, student, and again I am going to again available with the next sum in front of you. I am again here with the fifth sum of the exercise 1.3. The sum is saying what can be the maximum number of the digit be in the expansion block of the digit in the decimal expansion of 1 upon 7. Perform the division to check your answer. Okay student, you have to perform the long division here. I didn't perform here. I am not showing because the sum will be definitely lengthy. So I have already written the quotient here. The 1 upon 17 result will be 0.058823529411767 and after the 7 the repetition of this block will be. So I have write here the completely bar on these digits. Okay. So what is saying, after how many decimal expansion this will be repeated. If you are going to count, you will count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are 16 digits. After 16 digit, it is going to repeat. So what you learn from this chapter? What from this sum? And what is need of this sum here? This sum is here to teach you guys if there is a denominator. Okay, suppose the denominator is 17, but it must be the in its standard form. Okay, in co-prime form. So the number of the digits in the block of the repetition will always be less than this denominator. They can't be more than this denominator. We have to learn it. Because this is the 17, the digit can be up to 16. Okay, can be 3 digit only, 4 digit, 5 digit repetition, but it can't be of the 18, 19 digits repetition. Okay, guys, again I am coming here with the sixth sum before you. So this is sixth sum of this exercise 1.3. Some saying, look at the several example of rational number in the p by q form. Q not is equal to 0 for terminating decimal expansion. What property Q satisfy? You have to understand what is sum saying for the terminating decimal expansion. For the terminating decimal expansion. Okay. So I am going to tell you the 2 by 5 is 0.4. 3 upon 2 is 1.5, 7 upon 8 is 2.875 and 7 upon 10 is 0.7. You are saying, you are observing here all these decimal expansion are terminating. Okay, so he is saying what the property Q will satisfy for this. What the property Q satisfy. So I want to tell you guys the Q must be in the form. ओके, जो Q है वो किस फॉर्म में होना चाहिए या Q कैसा होना चाहिए? It should be a raised to power m into b raised to power n, where a must be 2. Okay, like 2. So it can be 2 raised to power m and b can be 5 raised to power n, where n, m and n belongs to whole number. इसका मतलब क्या है? जो Q है बेटा, ये किस फॉर्म में होना चाहिए? 2 raised to power m into 5 raised to power n, and m and n must be belong to whole number. Okay, so we will check it. This is 5, Q is 5, so 5 can be written as 2 into 2 raised to power 0 into 5 raised to power 1. So it satisfies this, because I have already said m and n must be whole number and 0 is a whole number. Okay, so 2 is similarly 2 into 1 into 5 raised to power 0. Okay, similarly 8 is 2 raised to power 3 into 5 raised to power 0, and 10 is 2 raised to power 1 into 5 raised to power 1. So you are also observing, you can say the m and n must be the whole number. Thank you. In seventh sum, it is written here, write the number whose decimal expansion is non-terminating, non-repeating. तो आपको ऐसे नंबर लिखने हैं, ठीक है, जिनका जो डेसिमल एक्सपेंशन हो नॉन टर्मिनेटिंग, नॉन रिपीटिंग हो. तो आपको पता है स्टूडेंट्स, those numbers whose decimal expansion is non-terminating, non-repeating, those numbers are the irrational number. Simply we have to write here irrational numbers example. So I can write here like that 7.3141141141114 and I have taken these examples from my side. You can write other also. So 0.10, 100, 200, 300 and pi is also a irrational number, so its value is 3.1416 and so on up to infinity. Now, because I know students, you are in 9th standard, you might be confused on this point, because you can think, sir, you are saying there is a no repetition, but there is a repetition of 1 1 1 1 1 1. My dear student, repetition must be of a block like that. This is, suppose this is 14, so again there must be 14. Okay, there is 114, so again must be there 114, then that is the repeating. But here it is 14, it is 114, it is 1114. So this is not repetition of any number 14 14 14 114 100 like this. So there is a no repetition. Clear it? Now I am going to next sum. The sum is 8 is saying find the three different irrational number between the rational numbers this and this. I have already told you on a number line, between any two rational number there are infinitely many rationals and irrational number, and the sum is asking only of the three irrational numbers. You can find out so many irrational numbers and your answer can be different from my answer. But I am also writing here from my side, the 5 upon 7 can be written as 0.714285, and there is a repetition of this below, so I am writing here bar. After that 9 upon 11 is 0.81, there is a repetition of 8, so I am writing it again 81 81 81 81. Why? Because there is this much block. Okay, so you see there is a 71 and there is 81, so there are many numbers between the 71 and the 81, so you can write here 0.72345696, but there is a no repetition and no termination, so this is an irrational number. 0.74255735 like that, 0.781239 and other examples you can take. Okay, now I am coming here to with the next sum 9, and that sum will be the last of this exercise. Okay, the last sum of this exercise 1.3, the ninth sum, is saying classify the following rational number or the irrational number. Thus already has been given the 5 sum here, and you have to classify whether these are the rational numbers or the irrational number. 5 different number already has been given here. So I am going to tell you the guys how will you identify, how will you tell whether these numbers are the rational numbers and the irrational numbers. Okay, I want to tell you guys this number the number is the root 23. So first of all I am going to tell you the answer. Answer is, it is irrational number. Okay, why it is irrational number and how will you identify this? I want to tell you guys, this is the number in the form root m. Okay, if m is not a perfect square. Okay, m is not a perfect square, root m is irrational. But if m is perfect square, okay, then root m is a rational number. Okay student, if m is not a perfect square, root m is irrational. If m is perfect square, then root m is a rational number. So I want to tell you 23 is not a perfect square, so root 23 is a rational number. Are you getting? Now you see here 225 is a perfect square. I am writing here m is a perfect square. 225 is a perfect square, so root m is a rational number. So this is a rational number, student. Rational number. Now why 225 is perfect? Because its square root is a natural number. Okay, so this is 50. So now 0.3796. Okay, This is, this is student terminating. And student, if the number is terminating, it is a rational number. So result is a rational number. Okay students, now again you are observing this is also terminating. Okay, so it is also a rational number. Now next fifth is non-terminating, non-repeating, because this is 100, 10, 100, 1000, but no repetition like 10, 10, 10, 100, 100, 100, no repetition like this. So this is non-terminating, there is a no termination, 3 dots are here. Okay, and because it is non-terminating, non-repeating, so it is a irrational number. Okay, it is irrational number. Okay students, with this sum, our exercise 1.3 of chapter 1 number system of class 9 from NCERT math has been covered by me. And if you are having any doubt, you can ask doubt after writing in the comment box. I will try to reply very soon, and you can also ask from your concerned teacher. Thank you students.